Engineering teams run on context, but the exact reasons why a database was chosen or a feature was scrapped rarely make it into formal documentation. That tribal knowledge tends to live and disappear in the endless scroll of Slack and Discord channels. The common fix is to point an AI search bot at those massive chat histories and hope it can find the right answers. This diagram shows exactly where that approach fails. When a standard retrieval augmented generation system feeds raw, turn-by-turn chat snippets directly to an AI, the model has to make sense of fragmented conversations. It struggles with missing context, leading to unreliable answers. Searching through raw conversational history doesn't produce usable knowledge. It just surfaces more noise. AI researcher Karpathy pointed out a crucial limitation here. Large language models are highly optimized to reason over structured, curated encyclopedias. They struggle to parse the noise of chat transcripts. Beever Atlas is an open-source solution built to bridge this architectural mismatch for development teams. This diagram illustrates its Wiki-First mechanism. Instead of waiting for a user query to search raw chats, Beever Atlas continuously pulls incoming messages and distills them into a structured wiki. The system organizes the data before a single question is even asked. By compressing scattered messages into clean documentation, the retrieval layer finally has a reliable, fact-dense target to pull from. To build this structure, Beever Atlas first connects to a workspace and syncs the channel history with its ingestion pipeline. Raw messages enter a 6-stage Google ADK and Gemini pipeline, extracting isolated atomic facts. The system deduplicates these, stripping redundant chatter into unique data points. These split into a dual memory system, a vector database for concepts, and a relational graph for entities.
The conversational chaos is now transformed into a machine-readable brain, ready to be accessed. That backend structure feeds two separate delivery services. The first is an interface built specifically for the human team. This dashboard visualizes the auto-maintained web UI. It uses the databases to generate concept maps, topic pages, FAQs, and glossaries. This automatically captures the project context that often requires manual summaries, or simply goes unrecorded. To ensure these summaries can be trusted, every claim in the wiki includes explicit citations. A developer can click any fact and trace it straight back to the original source message that produced it. For a new engineer joining a project, this removes the need to scroll through months of history to understand why a specific architecture was chosen. They skip the reverse engineering process entirely and start with a curated project history. But humans aren't the only ones reading this wiki. The second consumer of the Beever Atlas pipeline is the AI itself. The Integrated Model Context Protocol, or MCP, server acts as a bridge, connecting the knowledge base to assistants like Claude Code and Cursor. They gain 16 retrieval tools, independently querying the graph to understand historical decisions before writing any code. These local coding assistants now operate with a persistent, company-specific conversational memory. Fleeting conversations that used to vanish into the chat history are now captured and preserved as active assets. The entire archive of tribal knowledge is now completely queryable, instantly accelerating developer onboarding and expanding the AI's context window. Beever Atlas provides a scalable solution to the constant decay of information in enterprise communication. If this breakdown saved you hours of research, hit subscribe.